Hi, this is Adam Vinner, and today I'm going to explain my COVID test delivery robot. The robot is designed to follow lines in a parking lot and check each parking spot to see if there's a car. If a car is detected, then the robot will turn and approach the car so that the test can be delivered. If not, then the robot will just continue and skip approaching that spot. The robot provides an indication when it reaches an intersection, identifies objects, and successfully delivers a COVID test. If you listen now as the robot approaches the camera, you can actually hear the ultrasonic sensor because it's continuously monitoring its distance from any object in front of it until it's within 5 centimeters. Let's talk about the hardware. The robot is built around the Bobot kit, which includes the chassis, wheels, continuous servos, and a couple other components. Like I mentioned earlier, there's also the LEDs and the buzzer that are used as indicators. And then for following the line, there's an array of IR emitters and receivers. And for object detection, there is an ultrasonic rangefinder. And finally, the brain of the system is an Arduino Uno. Starting from the home position, the robot follows the line and enters the straightaway without accidentally identifying an intersection. Then the robot identifies the first intersection, but does not scan, as that marks the entrance to the parking lot. At the next intersection, the robot identifies it with a blinking LED, and then sequentially scans the front, left, and right directions for an object which represents a parked car. It doesn't see an object, so it continues. The control algorithm consists of a loop with 2 states, either yes at an intersection or no, not at an intersection. When it's not at an intersection, the code for line following is called. But when it is at an intersection, a chunk of code is executed that scans for objects, and then depending on the results of that scan, it'll navigate to the objects that it found and then return to the main path and keep following. Here we see the robot identified a left and a right object. So the object turns left and approaches, then it turns around, skips what it sees as an intersection, and then proceeds to the right object. Again, it turns around and proceeds down the main path. The robot only sees a right object at this intersection, so it makes a right turn and approaches and signals with the buzzer and the LED, and then it turns around. Here you can see the robot is robust enough to keep itself centered on the path. This intersection only has a left object. And finally, at the last intersection, there's only an object to the front, and you'll see that after scanning, the robot approaches the front object, indicates that it reached it, and then turns right to celebrate finishing the course. Thank you for watching, and feel free to reach out for more information.